Welcome to part 3 for recreating Wanda's magic, and in this part we're going to create the volume like I mentioned. And we're going to start by, again, getting into stream from this goal. And I'm going to start by using a transform, actually, because we want to scale it up a bit. As when you're working with volume, let's move this down a little bit, actually, so that it's a bit cleaner. When you're working with volume and doing volume sims, a scale this small, 0.1, is really hard to work with because volumes works better when it's a little bit bigger. So a cheat you can do is you can just do a transform, scale it up 5 times, and after the same you just scale it back down, and you'll get the results you need. So I'm just going to call this sim scale, and then I'm going to do a pyro source. I'm going to set this to source smoke and set it to pixels so we can actually see them. And I'm going to do particle separation of 0.04 and set it to a volume scatter, actually there, so now you can see the difference. And we don't need temperature, we only need density. And let's do a volume rasterize attribute so we can actually rasterize these points. This is basically just the points from volume and then setting the attribute called density. And this one ras density is just turning these points into volume. So we're going to rasterize density, and we're going to set the same voxel size. So I like just copying this voxel size and doing a relative reference to this one. So I'm going to set this one back to the 0.04. And the particle scale is also automatically set based on this point separation. So here we have our volume. And I'm actually going to change the sim scale to 10 instead. I think we need it to be a little bit bigger. And I'm also going to do an attribute noise on our density so that it's broken up a little bit and not just the constant blob you see now. So noise density, I'm going to do it's a float because density is float. And we're going to do a multiplication on it. So it'll multiply our density with the noise that we set here. And if I set this lower, you can see you start some very subtle shapes, but it's very hard to see because it's 0 to 1. It's as long as there's some density, it's kind of hard to see the difference. So let's do min max, so we can make it lower if you want to. However, if you do negative density, it kind of messes up in the simulation because it thinks it's sourcing in something that's negative. So I'm going to just remap it instead and drag it to something like this. And I think maybe 0.3 is good. Just do a little animation on it, a full scale of 0.5. So you can see this thing is moving and we're always getting some random density. I think that'll look nice. And we're also going to do an attribute noise on our velocity. So noise v. If you don't have, like, I don't have a velocity, but I can, well, like we've been doing with the noise, I can just create the attribute in the attribute noise because it's just adding it on top of nothing. And let's do this one with, let's see. I like, in order to see it, velocity, usually want to do 0 centered so that it's not going in a certain direction. And if I go really strong on it, you can kind of see the direction that it's taking. And let's set this to maybe like 5 or no. Let's start with something lower because we're going to add it in every frame of the sim. And we're also going to rasterize this this velocity. So now we're rasterizing our velocity and our density. And we're going to do a DAP network, and we're going to call this one smoke sim. And if we jump in here, we can put down a sparse smoke solver and put this into here, and then also a sparse smoke object. And this is where the smoke is stored. This is where it's calculated, and the sim is actually being done. And again, let me just reset this real quick. I find the best way to set up this, or to set up smoke in general, is to do some automatic centering of the bounding box. And you can do that by, first of all, add an extra parameter to your smoke object, and you can click here and then you do add sphere input, which will add this input into our smoke solver. And you could just point it to this ras density by clicking here and pointing it to let me see, ras density. However, a more procedural way is by doing up input path. Just do these 2 backticks on top left of your keyboard. Up input path, which is finding an input path for, if you do this, it's just going to look up 1 level. This is just saying, I'll just go up 1 level. Up 1 level is this level here. Press U to go up. And we're going to do this 0th input of what's one level above us, which is this 0th input of the DOP network. And if we middle mouse now, we can see that this is pointing to this volume rise rasterizer. And on our centroid now, we can use this input. We can do a centroid of -1, which is the -1 input. So when you create the spare input, it starts counting downwards. So if I add another one, it would be -2. But this first one is -1. And we're going to do d-x, so dimension x, which is 0, which is because this is already centered. So in this case, it's kind of already giving us what we have, or similar, but in other cases, this is very useful. So I'm just going to copy this, and for the y one, I'm going to do d_y, and d_z for the last one. And this will automatically center off our bounding box. And then we also do a volume source, so we can source in our volume. And I'm going to do first context geometry. This is the exact same as this does, but this just already has a drop down for it. And I'm going to click on something else so that I can go into source smoke, which is what I want, but it's already set to it, so you have to kind of like reset it. And then we remove the temperatures, we don't need that. And let's just hit play and see what happens. And it's working, but we do not actually, we want to enlarge fields to contain source. In case you're doing this in a different space, you would have to keep this enabled so that your source is also remaking the bounding box. But in this case, it would have worked anyways. And now we have a smoke sim, and let's actually make this look semi-decent. All right, let's start by lowering or upping the frequency of this by lowering the element size, maybe to like 0.4, because then we won't see it just go in two directions. It should go a little bit more spread. I wonder if this is, it is 0-centered. I think we're just getting unlucky with where it's going. Let's animate the noise to 0.5 so that this thing is moving around. There we go, that's working better. But it is a little bit too violent, so I'm going to set this to 0.1 or maybe 0.3 for the scale. And now we have some noise or some smoke moving around. But it is kind of static still. It kind of feels like it's going and then just stopping. And something we can do to make this, because what we're trying to achieve, we want this to move outwards constantly and then just die off quickly. We just wanted like a constant flow of smoke here. So and now it feels like it's stopping. So what we can do is we can actually add something called divergence. If we add density and then we do the target field to divergence, so this is where it's coming from, the density, and then we just target that to a divergence field. And we just set the scale high, or to really see it. It'll blow up like this. This is used in explosions. But we can set this to maybe like 5, and then we'll see it's constantly going outwards like this, which will be nice. And now let's kill it off as well. I'm just going to do a merge because I know I'm going to do a few more operators here. And I'm going to do wrangle inside here, a gas field wrangle. There it is. And we could use dissipation for this, but I find sometimes it's more controllable to just do at density times equal to a channel, which we just called we'll just call dense mult. And if I say multiply the density by 0.75 every frame, it should be dying off pretty quickly towards the end. But I feel like I misspelled density. There it is. So now, yeah, now you can see it's just dying off, and we have just this constant stream of smoke. And this is a little bit too sparse, so let's actually up our density in here to maybe, let's see, 3. That's better. And I also want to randomize it even more, so I'm just going to use turbulence, gas turbulence, which I'm going to set to a scale of 1 and a swirl size of 0.8, which will give us just a little bit more noise in here. So you can see that it's breaking it up even more. And we have some nice noise now, which is great. And let's see what happens if we up the density even more, because I want this to be pretty dense, so we can control it after the fact. That's nice. Let's lower this voxel scale to the same as we had for our source, which is 0.04, so that this is nice and detailed. There we go. This might be a little bit much, but it's a good starting point, and I think we're almost there for the smoke sim. All right, so I think we have a bit too strong forces. So I'm going to go 0.25 here and 0.7 here, and this should be a little bit more balanced. And let's just see what we get when we export this. So to export smoke sim, we can't use the same object merge. We're going to have to use DOP import fields, which is not connected. It's just a standalone node, and then you put the DOP network in the DOP network field, and then smoke here. But here we do the same as we would have done for the pop object, just smoke object, and then star. And this, once we select our smoke preset, we'll import our smoke into a subs level. And we can delete the CD, the color, temperature, rest, and I think we don't even really need the velocity, because velocity, like motion blur on volume, is really not used a lot, and especially not for stuff that's not too fast moving, but we'll keep it in case we want to add a little bit of motion blur to this. And then I'm going to use post process, pyro post process. And again, these are my default values. Just turn on convert to VDB, convert to 16-bit float. This is just a small compression, but we won't lose any quality. And then we're also going to resample the velocity to be twice as small, just so that it's a lot more memory efficient. And if you click info on this, you'll see that it's using 25 megabytes of memory, and with the compression, we're only using 11. So this will save us a lot of file space. And actually, before we do that, we're actually going to copy this sim scale. We're going to do action create relative copy, which is just copying the node and doing a relative reference for every single parameter. And we're going to drag this down here so that we can invert the sim. But now it's obviously going to make it 10 times bigger. But we're going to control shift left button to break the connection, and then click invert transformation. So now this will transform it back into the same scale as all of our other sims and our core here. And as you can see, I feel like it's losing a little bit too much density at the bottom here. So let's actually try and fix that now. If we remove this, we can kind of isolate part of it and see if it's still happening, to see if it's an issue of the turbulence we're adding or of the noise we're adding. And I think it's because of this velocity. So if we put this to 0, we'll see if it still happens. That seems more even. So let's just put this to 0.1. And this should be more even, I think. Let's see if there's one more thing we can do. Maybe on the density noise itself, it's cutting out a little bit too much volume. It seems fine, but we can, if we lower the pulse duration, it'll make sure that it's going really quickly between the different noise levels, and therefore it'll always be a little bit of smoke everywhere. And with those changes, I'm going to add back turbulence, maybe lower that one a little bit. This doesn't need to be too crazy, and I think that should be a better result for us. So let's stick with that, and again, I'm going to copy this cache node. I'm going to control middle mouse to get this back so that it doesn't overwrite the cache, and do cache smoke sim. And let's copy this start frame over to this one so that they're linked for pre-roll. And I think I forgot to do that with this one, so I'm going to do that on the, actually not that one, on the string one. So I'm going to copy it and paste it here. I think it's linked to this one. So now they're all linked properly, and let's sim this and see what we get. Okay, so this is the cache that we ended up with. It looks fine, I think, but I was comparing it to the size of the string particles, and it's way too small compared to what I know it needs to be. So, and I think these are actually going too far as well. So I'm actually going to go in here on the string and multiply the initial velocity on the attributes. If you go to the pop source and the attributes and multiply the or inherent velocity to 1 times 0.4 is equal to 0.4, of course. And if we cache this as version 4, just give this a second to cache, it should be a lot smaller. I think they were going way too big earlier, and this is why it's often good to kind of have some sort of reference scale. I'm kind of eyeballing it now, but it should still work once we have this little fix here. And we'll compare it to the scale. If you hit W in here, you can compare it to the scale of these, which I think is working better now. And compared to the smoke as well. It's working better, but the smoke is a little bit too small still. So I'm just going to do a transform on the smoke, 1.2 maybe, and compare all of these, which are starting to get more in line. But I do, while I'm working on the strings, I actually do want them to be a bit bigger, or sorry, for there to be a bit more of them. So I'm going to go set this thresh to 0.12 and recache this again. And this is working better, but I think the shapes are a little bit too simple. So I'm actually going to go, let's see, let's find the frame where it's working. And set this noise back to maybe 0.1. Actually, sorry, if we just up the roughness, they're going to be more complex. So I'm going to set this back to 0.55 and set the element scale to 0.17, 0.15 maybe. And this should give us some better shapes. So I'm going to recache this as version 5. Okay, now I think they're looking good here. And that's enough distraction. Let's go back to the smokes we're doing. And like I mentioned, I want the smoke to be sort of the same scale, or at least be reaching the ends of this. So I'm going to scale it up even more. This might be a little too much, maybe 1.8. And I think that's going to work better for what we want. And now what we want to do is we want to remap this density, because I don't actually want it to be super dense in the middle. I want it to be more dense around the edges and softer in the middle. And we're going to use the volume wrangle for this. This is an attribute wrangle, so let's put down a volume wrangle. And let's just try by first doing at density is equal to channel ramp. Let's just call it ramp, and based on the density. And the problem with this is that this only goes from 0 to 1, so it's kind of hard. So if we want to say at the end it goes low and then at the beginning it goes big, it sort of works. It sort of gives us what we want, but we don't have the full control over every value that's higher than 1. So let's actually just remap it beforehand. Let's do at density times equal to, or actually we want to do divide equal. So we want to lower the value down in the beginning. So we're just going to call it let's see, I'm just going to call it mult, because we're multiplying it after the fact. So first we're going to divide it, and then we're going to do the ramp, and then afterwards we're going to multiply it back. So it's not changing the value at all. See, if I double backspace here, it's going to turn off the ramp, and if I change, obviously it's 0 won't work, but anything, it's just going to go exactly back to the value we had. But what's nice about this is we can remap the range of which we're using this density to. So if we go higher, we'll have a lot more control over where we're remapping it. So I'm going to go to at around 15, and then I'm gonna make it 0 at the beginning. Of course, we don't want to introduce like this, that's way too much. But at the end here, instead of having it high like it usually does, where it gets very dense in the end, I'm just going to say that there's no density at all in the center of this smoke sim. And I don't think we need to go that high there. Let's just put it somewhere here, and wrap it something like this, I think will work. The difference now is, yeah, you can see we're kind of inverting where the high density is. Oops, yeah, click this to make it bigger. Let's compare that to this one. I think that's a good size. They're about the same size. I'm just going to call this remap volume. I'm just going to call this one scale up. And let's again use our B-spline to smooth this out a little bit. There we go. And let's start by using this. And I think it's a little bit big here, so let's do 1.7 instead. Perfect. Now let's say this, or put a null under, because we're basically done with the volume now, and call it out smoke. And same deal here. I'm just going to copy a geometry node, call it render smoke, and point this to the out smoke. Let's see, I'm filtering by rasterizing. Out smoke. And this time we're going to remove the material, because we're going to create an own material for this. For the smoke. Okay, so let's create this smoke shader. We're going to go into our material network, and I'm going to do a pyro shader. I'm just going to use the pyro shader classic. That's the one I'm most used to. I'm going to call it smoke shader, and first of all, I'm going to set the color to 100 to get the same red. And everything I'm just going to leave the same. The density is fine at 1 for now at least. And then I'm going to assign it here. And we're going to go into out, copy again one of these. I'm going to copy the one without the velocity, and then call it smoke mantra. And go into the objects and point that to our render smoke. And I know that this will not show anything because smoke is not emissive like our particles. So we're going to have to add a light to actually see this. So I'm going to add an environment light, which is just a spherical light around the whole thing, around our whole scene, which we'll call HDRI because we're going to actually put an HDRI in here in a little bit. And we're just going to point that to our force lights. So let's just have a look at what that gives us. I'm going to go into the camera and zoom in just a little bit and unlock it. And go into the smoke here and hit render. And it's going to take just a second to prepare the scene. But this should work just fine. And it's going to look pretty boring now. It's just going to be completely white. Sorry, it's going to be red, of course, because we set the red color. But to make this more interesting, we're going to light up the inside of the smoke with the core particles that we have here. So we're going to use this as an emissive particles, and they're very hard to see now. But let's take this geometry and let's copy it. So I'm just going to put it under here and call it prep core particles, because we're going to prepare them to be emissive or like actually turn into light. And I'm going to jump in and just do an attribute triangle and just say quickly that at alpha is equal to 1 so that we can actually see them. So here they are. And we don't need all of them. It's a little overkill to make all of these one emissive geometries. So I'm going to say that if random at ptnum, so if a random, every particle gets a random number between 0 and 1. And if it's greater than 0.1, which means 10% of them, we'll remove them because we only need 10% of these particles to be emissive for this effect. And that leaves us with 18,000 points, which is still a lot of points. And then we're going to do a copy to point, and we're going to put this into the second input. And in the first input, we're just going to put a primitive sphere. So if you make a sphere primitive and put it here, you'll see that each point now has a primitive sphere copied on top of it. And then we're going to set a null and just call it out. So a primitive sphere is able to be a light source. So what we can do is we can take this, let's move this a little bit onto the side, and we can click on geometry light while you have that selected. I think you might, yeah, no, that's working. And then call this core particles geolight. And I'm gonna, what's sometimes annoying is that this will try and visualize in the viewport, so it'll be really slow sometimes. So just turn it off like this and turn off enable in viewport. And now let's try and render our smoke again with this as light source. So I'm going to go into my out, and in the light source here, I'm going to select both the HRI and the core particles geolight, accept pattern, and render out the smoke again. I already saved this, so let's see what this gives us. And it might need to be a lot stronger, and this here we might need to tone down because it's just going to be red. Yeah, we're not seeing really any difference, but if we boost this to say times 100, you're really going to see it start there. But this is obviously too much, so let's try and fine tune it a bit. I'm gonna actually set my HDRI to 0 so that we can just see the influence of the core particles. Let's just see what that looks like. It should be pretty similar because they're already so strong. So let's say maybe times 5. And that's starting to look good. If we tweak this a little bit, maybe times 10. I think that's a great starting point for us. Now, what we can do if we want, so the problem now is that we're going to have, if we have both the HDRI and the core particles together, that kind of limits us because we're stuck with them both baked into the same channel. But we can go onto our mantra here in the images and add another image plane and add the combined lighting per light. What this will do is it'll separate out each light into an AOV that we can then control separately in comp. So I'm going to set my HRI back to 1 and save this snap here. And let's see, let's just let this render. And if we click here, we can see that our HDRI and our core particles both have their own layer now in our EXR. So that's really handy and really good for us to use when we're compositing. All right, let's actually add a character now, and we can do that by going to mixamo.com. And if you go on the characters page and just search for bot, you can find this guy right here. and just click use this character. And if you download this just as an FBX and T-pose, we can put this into our Houdini folder. So I'm going to go into my Houdini folder here, and I'm going to do right click, new folder, call it assets, and I'm going to pull this into the assets folder. And next, back in Houdini, I'm going to do an FBX character import. And when I go to the FBX file, I go into my assets and select YBot. And now I'm actually going to position my camera correctly as well. Go into the camera, lock it, and give it a position around here. Now, in order to put this into a pose where it actually looks like he's generating some magic, let's do a bone deform. And this will allow us to use the rig that comes with this and change the orientation of his arms and fingers and all that. So we can do a rig pose to do just that and put it into this output here, which is the deform points. This is basically the skeleton. So when we have this selected, we can click on this, press enter to get up our controls. I'm just going to do shift F1 to hide this. And now we can start just rotating and posting this as we want it. So I'm going to rotate it down like this. And angle it out a bit like this, and then I'm going to take this elbow and angle it upwards. You can play with this to whatever pose you want. This doesn't really matter too much. This is more just for presentation. I'm going to angle this one in a little bit and take the fingers, spread them just a little bit to be more of a dynamic pose. And let's also take the thumb here and angle it down a bit and out a little bit. And I'm going to take the thumb and angle it like this, and then take these joints as well and just angle the finger kind of up a little bit, or the tip of the finger, and then angle it a little bit up. But mainly it's just the tip that we want to angle up, because I want to still, you could angle them up a lot, like all of them, but I kind of want to see the core, so I'm just going to do like a subtle one instead, so we can see the whole effects inside of the hand. And something like this. So something like this looks like this from this angle. I think I want them to be a little bit more dynamic. I'm just going to play around with this a little bit until I have a pose that I like. So I ended up with something like this. You can see I moved the arm down and just made these a little bit more dynamic. And I'm going to go ahead and move the camera in even closer because I really want to see the effects. Also angle this head to be looking at it. And now we have something like this. I think will be nice. And then I'm going to just put a null under here, call it out character, and I'm going to do attribute delete because I just want to delete everything that's on this. We only need the actual geometry. Maybe we want to recompute the normals. No, it's fine, it already does. Okay, so we have nothing here, and that's good. So let's create a render node for this one too, call it rndr char, make it red. Could have just copied one, but that's okay. And point this to our, let's see, Wanda magic out character. So there it is. And let's make a material for this character. I'm going to use a principled shader and call it char shader. And let's start with this, and we can tweak it as we're doing the render. Let's go back into our outnet. I'm going to copy the smoke one and call this one, because we actually need the same, the light AOV. We're going to need the same one here, so just make sure you copy the smoke one and call it car mantra. And let's go into our objects and set this to the character. And we're going to keep the same lights, HRI and the core particle geolight. And let's just try and render it. And this is really going to help sell the scene because we're going to have light from our particles being cast onto the character. Let's see, we're isolating the core particles. I think there's something, because we should be seeing the core particles. Sorry. We should be seeing the core. There's the HRI, there's the core particles. I'm not too sure why we're not seeing them. Let's see why. Looks like we don't have any particles. Oh, there they are. Oh, never mind, of course, because they're way down at his feet. We're going to have to reposition these. But at least this is working, and we'll do the proper shading of this after reposition our magic here. So that's the next step, we have all of our passes there. We have our smoke, our tendrils, and our core particles, but they're nowhere near his hand. And there's often you create an effects and then you have to actually put them into a scene. So I'm going to show you the best way that I think of how to do that, which is pretty procedural. And we're going to start by just transforming it into space. So I'm going to do a transform called move to pos, move to position. And what I want to do is I'm going to actually go out there. I'm going to turn off my visualization for everything except for the character. And if I go back in here now and put this to show all objects, that'll be there, and we can position our objects or our particles into the right position. So I'm going to go and select this view as disk so I can see them better. And then I'm just going to move it right into his hand. And we can scale it down or up depending on what we want now. So which is going to be nice to have that ability. And I think something like this might work. Let's see. Maybe they're a little bit too big for 5. I'm going to make sure this is actually in his palm. And that's looking good. So the problem now they might not think about is that the particles, when you scale it down, the particle scale does not scale down. So they're going to be way too big, and it just looks like a blur now. So we're actually going to create a wrangle and counteract that. So I'm going to call it mult p scale. And we're going to do at p scale times equal to channel p scale and create this channel. And then we're going to do that, copy the uniform scale and put it in here so that these particles are also scaled down when we scale down this. As you can see, it's working perfectly. And I'm going to color this as well a bit of a green, and this one this bluish color, just so we can see some difference. And then I'm going to copy this action, create reference copy onto the filaments so that they're also copied perfectly. And let's move this down now. And I would do the same for the volume. Let's actually do the same for the volume. I'm just going to copy these now because they have the perfectly copied reference. However, the volume is a bit different. We can't multiply the p scale of the volume. However, we have to multiply the density of the volume, because what happens when you scale up or down a volume, the density changes because of the scale. So it gets very dense when you scale up and gets very low density when you scale down. So we're going to do a volume wrangle and do the inverse of what we did with the p scale. So we're going to do mult density, I'm just going to color it blue, and at density divide equal to the channel scale. And I'm just going to create this parameter and then copy this one from here and paste relative reference. And as you can see now, it's scaling it back up to the, if I just break this connection, I can scale it and still keep the same density. And that's how I can position it. And now we can render our character again, and it should have the geolight that we were missing earlier. But I think we're going to create a separate strength. Yeah, because there it is, but it's a little bit too weak, so let's fix that. All right, so let's fix that by just quickly going into this, or going to object level, copying this, and creating a separate one, and we can call this one core particle zeolight char, and then this one can be smoke, and then let's boost this one by, say, 10 times for the character. And if we go into our out and we select the HDRI and the character for this one, and the smoke should still have the one it already had with the smoke. And this should already be boosting the strength of this 10 times as it was before. And this, we're still going to do some shading on this, but yeah, it's a lot stronger now, so this is going to work out better. And let's actually use an HDRI now. So let's use the HDRI that comes natively with Houdini. If you go into the file picker here and then click HDRI, we can use the Skylit Garage, as I think this one has some nice contrast that we can use. So let's just see what happens when we apply this. And yeah, it gives us a lot better shading. So we're going to use that. And then we're also going to go into the character shader. And I like just putting the colors to 111 for the character. Did we apply this material? Looks like we didn't. So let's apply it. Character shader. And then I like using the albedo multiplier to actually lower it so it's easier to see. So we can do it all at once. So 0.1, I'm gonna up the roughness to 0.65. And I think this is a nice look for our character. And I'm also going to rotate our HDRI a bit. I'm going to save it and then rotate it by 90 degrees. And then save the snap, rotate it by another 90 degrees. And save it again and rotate it by a last 90 degrees. And when we do this, you can kind of see which orientation of your HDRI looks better. And I would say this one, the second to last one, which is 180 degree, looks the most dynamic. So I'm going to set it to 180 degrees. And I'm just going to delete some of these snapshots. And there it is. Now it's looking a lot better. All right, let's get this ready to render. And there's a few things we want to do first. I do actually want to boost the particle count a little bit of the sim. And I want to add pre-roll to all of them as well. So on this first sim here, points from volume, I'm going to set it to maybe times 0.8, so we get twice the amount. And I'm also going to set the start frame to minus, let's see, 50, so we get 50 frames of pre-roll. And I'm going to do that for all of these. And then I'm going to recache them all, and then I will be right back once these are all recached. So just set it to minus 50 and make sure it says minus 50 here. Or actually, it would be fine with 0, but it's nice to have. And then just do save to disk on all of them. All right, they're all recached now, and since I have twice as many particles in this cache now, I'm going to go ahead and multiply the p-scale by 0.75, just so that it's a bit more aligned with the look we had earlier. And yeah, these ones as well have 50 frames of pre-roll now, which is nice because that gives us already stringy particles from the beginning, and same with the volume. And I'm gonna render this again. I wanted to boost this a little bit more, the geolight, so I'm gonna multiply it by 2.5 again, so 250 intensity now in total. Let's just see what that gives us. I want it to be pretty strong. We can dial it down in Nuke as well, but if we isolate them, yeah, this is looking better. So let's set the resolution of our camera to 1920 by 1080. This is the transform, by the way, if you want to copy it. And we're going to just render again. And what we need to do now to prepare all these to render for Nuke is we're just going to set the amount of sampling to be correct, or to be high enough so that we don't see noise, or at least noise that's acceptable for us. So this is now 1080p render, and I think the noise level is already set to 0.01 on the noise level. And with 3 samples in 1080p, this is basically a noise-free render, so I think we're good on this one. I'm going to go to the core particles and render them as well. And we're just going to do the same thing. We'll just render it and see if we feel like the noise level is fine. I think this one's fine. I'm just going to go to another frame as well. You can just set this to 5.5 and then compare to what you had before, but it's really not a big difference. So we're going to stick with this one. This one is good. Now the string particles, this should be good. The smoke particles are the one that's going to be a little bit harder to tweak, but we'll just shouldn't be that bad. But let's see the string now. This one's looking good too. We can go 4.4, not any difference. So let's just stick with 3. And finally, our smoke mantra. This one will take a little bit longer to render because smoke, especially if lit up by particles, are quite heavy. But it's really not that bad, even with this resolution. And this should be basically noise-free. Well, no, not really. There's a bit of noise here, but we're not going to use this one too much. It's not going to be too strong, so it's okay if there's a little bit of noise. But let's maybe set this one to 4.4 in the samples, which should clear up some of this. Yeah, so that's cleaning up enough noise for me. And since it's smoke, I'm actually going to overwrite the camera resolution to 2/3, which is going to be back to 720 p. That's generally enough for smoke because it's kind of a soft element in itself, so you don't really see a difference in the resolution unless it's super high res, and this isn't like super high res smoke simulation. So this will just save us a lot of render time. It'll be like twice as fast to render. So let's do that. But since we're doing that, I'm going to up the pixel samples a little bit, and yeah, this should be good. I'm fine with this. And finally, I'm going to set some phantoms or some mattes for this. So I'm going to select all of these, and I'm going to go to force matte, and I'm going to set render character, which is going to make it so that the character is obstructing these renders. Because let me just show you the difference. Because when we're rendering, we don't want them to just overlay each other. We want them to be properly with the correct depth. and this should make sure that they have that. So we should see some fingers poke through here now as we're rendering it. And yeah, there you go. So this will be nice once we composite it together properly. And I think we're all set now. Right, so we're almost done now. I'm just gonna make a small change to this core pop sim. I went in and I multiplied, let's see, I multiplied the pop win amplitude by 1.1 and this roll size by 0.9 just to create a little bit more detailed, and then I recached that. And I'm also gonna go into this fade alpha, let's visualize this, actually, sorry, the mult noise alpha, and drag this a little bit to the left and this one a little bit to the right to create some contrast. And the element size, it was a 0.1, I'm multiplying it by 0.7. And with this, if I render it, I just did a few tests there to nail down the look. It should be just, yeah, it should be a little bit better and have a little bit more contrast and be a bit sharper. And the very last thing we're going to change before we render is just scaling up the smoke. Let's see if I visualize it with this. It's a little bit smaller than I want it to be. I want it to be a bit bigger, so 1.2, actually 1.3. Let's see, that should be more like it. Let's settle 1.25. And with that, these passes should all be ready to render. So I'm gonna go into my out. I'm gonna connect them all together and make sure they're all, let's see, they all have motion blur on, which is good. And select them all, go to render frame range, and it has the correct camera. The images will be saved into a render file. And I'm actually going to do a version 1 on behind all of them in case I want to render a second version. This will let me just version up quickly like that. And yeah, let's just click on this, the last one in the chain, click on this button and frame by frame and hit render. I actually found one thing I wanted to change before we do the final render, just with the smoke. I think we should scale it back down a little bit. It was a little bit too big, I realized, so do multiply by 0.8. And also on this volume remap, I just changed it to be a little bit more dynamic, a little bit sharper like this. This is the old one, and this is the new one, so you can copy this one and multiply it by 0.8 as well. And then finally, last thing, for the sim, I also added the gas disturb, set the mode to block based, and the block size to 0.15, and the strength to 5, just to break it up even more. And I multiplied the turbulence by 2.5, and the swirl size by 0.5. And then I recached it, and with all those changes, we are ready to render our simulations. And I will see you in part 4, which is the final part of this tutorial series, where we will do the compositing for this effect.